Hey Chileans, it's your girl Anne from Chill with Anne, and today we're going to do something a little bit different. Today we will be focusing on some chemistry, and as you can see on the screen, the topic is structure and bonding. Let us look at what the image on the screen is saying. So, two atoms are talking together. I am about to lose an electron. Are you sure? I'm positive. Now, you might be a little bit confused as to what is going on within the image, but as we tip into the topic today, I hope you guys get a better understanding of what exactly is structure and bonding. Now, before we can dive right into the bonding aspect of the topic, we have to have a little understanding of few things. So, atoms perform the action of bonding when they are unstable. In order for an atom to become stable, one should pay attention to its valence electrons. Now, what exactly are valence electrons? Now, these are electrons found on the outer shell of an atom. These are determined based on the electronic configuration of an atom, which derives from the atomic number of the element. Sounds a little bit confusing, don't? I'm here to help. Now, the first thing we're going to focus on is the atomic number of an element. Now, the atomic number tells the amount of protons or electrons of an atom. Here is a diagram showing where we will normally find the atomic number. So the atomic number is usually at the base of the element, while the mass number, which is the number of protons plus neutrons, will be found at the top of the element. Let's move on. Now, CXC requires to learn the first 20 elements of a periodic table. And while learning these 20 elements, you must know their atomic number. Usually, it is recommended that you know the first 20 elements in order so you can easily identify the atomic number. These 20 elements include hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silica, phosphorus, sulfur, chlorine, argon, potassium, calcium. These are in order. So what we're seeing here is that hydrogen is the first element, thus its atomic number is 1. Helium is the second element of the periodic table, thus its atomic number is 2. Lithium being the third, its atomic number is 3, and so on. Potassium, 19, its atomic number is 19. Remember, you have to know these first 20 elements out of your head along with their atomic number. So let's backtrack a little bit. Here we said the electronic configuration of an atom derives from its atomic number. So now that we know what exactly our atomic number, I will say that atomic number is the same as proton numbers and electric numbers. In other words, if, for example, lithium atomic number is 3, thus it has 3 protons as well as 3 electrons, while mass number tells the amount of protons plus neutrons. Let us continue. Now, when we're looking at an atom, we have to identify certain key things first in order to come up with its electronic configuration. Now, on the first shell of an atom, that shell contains only 2 electrons. That is the maximum amount of electrons that shell can hold. So either 1 or 2, but it cannot pass 2. For the second shell, it contains 8 atoms and the third 8. So you can't go beyond 8 electrons, and that's how you will be able to determine the electronic configuration. So let us look at hydrogen for a bit. We said that hydrogen is the first element of the periodic table, thus its atomic number is 1. So therefore it will have only one shell because it only has 1 electrons or 1 protons or 1 atomic number. So its electronic configuration will be 1. Let's just look at some more example for a better understanding. So here we have a table showing a list of the 20 elements. Let us look at helium. Helium atomic number is 2, thus it has its electronic configuration is 2. Lithium is the third element of the periodic table, thus its atomic number is 3. Remember, we stated that on the first shell of an atom, the first shell can only hold 2 electrons, thus any remaining will automatically go over to the second shell. Thus, lithium electronic configuration contains 2 electrons on the first shell and 1 electrons on the second shell. So that's 2 and 1 for the electronic configuration. Beryllium, it is the fourth element of the shell of the periodic table, and as we stated that only 2 elements can hold on the first shell, so anything remaining you put it over to the second shell. Thus, beryllium has an electronic configuration of 2. So in other words, the electronic configuration can tell how many shells are occupied. Let us go a little bit further down. So here we have magnesium. The electronic configuration of magnesium is 2A2 because its atomic number is 12. So on the first shell, we have 2 electrons because that's the maximum amount of electrons that shell can hold. On the second shell, as stated, the second shell can hold up to 8 electrons. Thus, we have 8 on the second shell, and anything remaining we put it on the third shell, which is 2. Thus the electronic configuration of magnesium is 2, 8, 2, and the same goes for the rest of the elements. Let's look at what is meant by the term periods and group. Now, period can similarly be related to electronic configuration, because what the period does is also tells the amount of shells that is being occupied. Here we have hydrogen only having 1 electron, thus we say it occupies only 1 shell. We have carbon, it has a number of 6 atomic number, as well as it occupies 2 shells, thus the period is 2. What the group tells though is the amount of electrons on the valence shell or on the last shell of an atom. So here hydrogen only have 1 shell, thus the last shell is 1, so it's in group 1. And helium has only 1 shell, so its last shell is 2, so it's in group 2. Nitrogen has 5 and its outer shell, so its group is 5. Let us see if we can find a better example. A key thing to note before we move on, that elements in group 0 are considered to be stable and unreactive. Example, helium, argon, and neon. So because they have 8 on their shell, we wouldn't consider them to be bonding because they are already stable. They already have a maximum of 8, which is required on the second shell. I know it might be a little confusing, but we're going to get practical as soon as possible. So let us look at this diagram here that shows the structure of an atom. So the atom has a central area, which we would call the nucleus, and it consists of protons and neutrons. Around the nucleus, you have the first shell, which consists of 2 electrons. Then you have the second shell, which consists of 3 right here. The maximum on the second shell is 8. So we can say the total amount of electrons here, we have 2 on the first shell and 3, so that's 5. Thus its atomic number is 5 because the number of electrons and protons is the same number for the electronic configuration. Thus this atom here is boron because it has a total of 5 electrons. Let us check back on our table to see if we're correct. So we're saying that the atomic number is 5. Here we have boron, so 2 and 3 is 5. So here boron has 2 electrons on its first shell and 3 electrons on its outer shell. So let's see if we can draw a diagram for these examples. We stated that, let me get my pen. We stated that hydrogen has an atomic number of 1 because it is the first element of the periodic table. I don't know why I keep on saying atomic. So let us draw our nucleus. Don't mind my drawing. I would say within the nucleus we have protons and neutrons. And our first shell here. Now hydrogen only have 1 atom, 1 electron, thus this will be its atomic structure. Let us look at carbon. Let us write the electronic configuration of hydrogen. So the electronic configuration is 1. The second one is carbon. The atomic number for carbon, let's check back on our table. You need to know this is 6. 4 plus 2 is 6. Thus, it is the 6th element on the periodic table. So let us draw them. So since this is a nucleus, we said that the first shell, let's just kind of neat this up a little. Time is going. So the first shell, so this is a nucleus which contains protons and neutrons. The first shell consists of 2 electrons. I remember the atomic number for hydrogen is 6. So thus we have 2 right here. So we still need to find somewhere to put 4. The remaining 4. Thus we're going to need another shell. I will put the remaining 4 on the second shell. Sorry if my writing ain't neat. Take some time. So yeah. So we have 1, 2, 3, 4, 5, 6 electrons, and the electronic configuration would be 2, 2, 4. 2 on the first shell and 4 on the second shell. And we can say that the period for this element is period 2 because it consists of 2 shells, and it is in group 4 because its last shell, which is also known as the valence shell, consists of 4 electrons. 1, 2, 3, 4. Let us look at chlorine. Chlorine atomic number. So the atomic number for chlorine is 17, right? So let's draw the diagram for chlorine. So we have the nucleus, which consists of protons and neutrons. The atomic number is 17. So here we add 2 electrons for the first shell. 2 from 17. We're left out with 15. We said the second shell can hold up to 8. So we're going to add 8 on the second shell. Bear in mind the electrons can be represented by an X or a dot. Right. I'm having some problems drawing these, I don't know what's going on. Alright, so let us go up top.